Hello everyone. Today I'm going to start a new lecture series on digital VLSI design. This is semester 5 subject from Mumbai University. And today I'll give you the brief outlines, brief overview about the syllabus. This is basically Mumbai University syllabus, but the syllabus is mainly same in all the universities. You can go through it. Okay. So outlines are here. There is a prerequisite brief overview of syllabus, objective, outcome, what are the reference books, and how many types of software you can use for the experiments. Okay. So let's start now. Course prerequisite means which prerequisite subjects necessary for the subject. So electronic devices circuit, that's in SAM 3 subjects, digital system design SAM 3, linear integrated circuit SAM 4. So basic knowledge of these subjects are required, but it is not compulsory. If you don't be sound in those subjects, still you can learn the subject, this subject. Don't worry about it. So next is there are 6 modules in the syllabus. So we'll start from brief introduction module 1. So module 1 is review of MOSFET operation and fabrication. Why the EDC subject is required? Because of MOSFET. MOSFET metal oxide semiconductor field effect transistor. So whole VLSI depends on the MOSFET, and in MOSFET basically E-MOSFET, enhancement type MOSFET. Okay, so here are the overview of VLSI design flow means how the hierarchy works. Hmm? Uh, Review of MOSFET operation means that if you remember cutoff region, depletion region, saturation region, so you should have the idea about it, how MOSFET works. Then how MOSFET behaves like a capacitance. MOSFET is scaling, there is a constant voltage scaling, full scaling. Scaling is a requirement because we are in the nanotechnology. So as per technology advances, the size of feature chip size reduces and we have to do the scaling. So this is MOSFET scaling. Then short channel effects. So if you are having the brief knowledge about these all, so it will take only 3 hours. So this is according to the Mumbai University. Okay. And fabrication of NMOS, CMOS, and the design of this depends on lambda based rules. Means if you will talk about the layouts of MOSFET, then there are lambda rules and micron based rules. Okay, lambda rules are most important. So this lambda rules, the novel MOSFET. If you learn about the MOSFET, then there is a noble MOSFET. In noble MOSFET, there is a FinFET, GA, CNT, FET means carbon nanotube field effect. So knowledge of this will be in this module. And the books, basically, these you can say if you are talking about the numericals, and numerical can be asked in the MOSFET capacitors. Okay, otherwise it's a conceptual topics, so theory topics, but conceptual topics. And books are Sang-Woo Kang and Yusuf Lablisi, John P. Umaira, Jan Rababe. Okay, Rababe is for the digital part, but only this book, Sang-Woo Kang, is enough. If you go through this book is enough. Okay, and the CEO, that's the course outcome 1, 2, 3, and after the model description, there is a course outcome. Okay, then next is module 2. Module 2 talks about the combinational CMOS logic circuits. If you remember, I was talking about the prerequisite subject. The first was electron devices circuit, that is for the knowledge of MOSFET. But the second one, digital system design, means you should have the basic knowledge of all the digital circuit. In digital circuit, you know that there are combinational circuit and a sequential circuit. And difference between those is combination circuit means present output depends on the present input, and the sequential circuit means present output depends on previous output and present output. So here we will learn from the MOSFET point of view. Okay, this is and if you learn the MOSFET, there is a MOSFET, there is NMOS, PMOS, CMOS. Okay. So NMOS, PMOS is a N channel, P channel, but CMOS is a complementary MOS with a combination of NMOS and PMOS. So CMOS inverter, how CMOS works like an inverter, then what is a BTC, voltage transfer characteristics, how the noise margin will be calculated, what is the delay, what is the power, because these are the main design trade-offs for the CMOS. Okay, so all the design trade-offs you should have in mind when you are designing something. Okay, and the layout of definitely all the circuits. Then once CMOS is clear, CMOS basic inverter is clear, then you can realize CMOS NAND gate. Then gate means y equals to a dot b bar, and NOR gate y equals to a plus b bar. Then complex CMOS logic means any combination, any circuits like y equals to ab plus cd bar, y equals to ab plus c, is any type of circuit, any equations you can design through the CMOS, and definitely layouts of the all the circuits. Books are same. Again, there is if you are talking about the numericals, numerical will be for the power dissipation, noise margin, otherwise all the concept of subject. Analytical means if you are talking about the design trade-offs, then there is you have to do analysis. And design means we are talking about the layout. So that is, it is analytical and design based, but concepts is always there. So concepts knowledge is behind in every topic, but apart from that, this is analytical because the numerical part is there, and the layout is the design based. Okay, and the books again same. The CO is all COs. Okay, next is first design logic styles. Okay, a logic style means designing means there are different types. Means static CMOS means there is no clock used here. That is static. But if we are using a clock, because clock is very important memory part. So if you are using clock, that it becomes a dynamic logic. Okay. Then there's a pass transistor, transmission gate, pseudo, dynamic, domino, NORA, zipper, C2MOS means CCMOS, clocked CMOS. Then if it is clear, then we'll come to the flip-flop, latches flip-flop, then you know SR, JK, T, D, all the flip-flops covered here. But the design is styles are these. Means if you learn these all the design style, what is static CMOS, what is pass, what is pseudo, what is transmission, then in the exam it can be asked design JK latch using the static CMOS. Design masters of JK flip-flop using the dynamic logic, using CCMOS. Okay. Then once the flip-flop clear, then you can design the shift register, mux, decoder, full adder, all these topics. Okay, the books are same. And again, this is conceptual and we are realizing the circuits are conceptual realization based topics. Then the module 4 is about the memories, semiconductor memories. Okay, now the memories, you know, ROM and RAM. And you know the difference between ROM and RAM, but here is a designing part. Okay, and if you're talking about designing 60 means 6 transistor means you know the SRAM is static RAM. You have to learn the operation design strategy, what is the current, leakage current, sense amplifier used in the designing layout of this. But specifically it is mentioned 60 SRAM is 6 transistor SRAM, 6 transistor MOSFET used as static RAM. Okay, then one SRAM is clear, then DRAM dynamic RAM. Definitely dynamic, we're talking about there is a capacitor used, charging, refreshing is there. Okay, so here 1T and 3T means 1 transistor and 3 transistor. Then after RAM, there is a ROM and a ROM arrays, and then there is a flash memory. And flash memory, it's mentioned NAND flash memory and NOR flash memory. So this whole module is regarding the memories. So definitely it's a conceptual subject, and when you are talking about SRAM and DRAM, definitely there is some comparison between SRAM and DRAM. So you can say it is an analysis. We are doing some analysis. So it's a conceptual and analytical based subjects, and this is definitely same books, okay, in all the books, but mainly I always prefer Sangmokan. Okay, CO 1 to 5. I'll mention the CO after the module description. Next is model 5, that is regarding data path and system design issues. Once the everything is clear, means once the combination circuit done, sequential circuit done, memory is done, then we will talk about the adders. Okay, in adder adders, that is a combination of full adders, and with the combination of full adder there is a ripple carry adder. After ripple carry adder there is some issues. Then next is carry look ahead adder, CLA adder. Then after that carry save adder, carry select adder, carry skip adder, all types of adders, and then multipliers using the MOSFET you will learn here. After this, then what is the on-chip clock generation, how clock generated, how clock distributed, how it is stabilized. Okay, the interconnect delay, you know the system delay, but apart from that, when the system size reduces and the transistor size increases, then there is issues of connection between different blocks. Then there will be a delay created, that is called interconnect delay, due to the connections. And sometimes the delay dominate your circuit delay. So how to calculate this delay? What is this type of this delay? How to do scaling of this delay? And then definitely the crosstalk. Okay. So all this we will learn in the module 5. Then last module is RTL Design. It is a high level state machine design. And there is some case study. Here you will learn the case study of soda dispenser machine and the FR field. Okay, so this is the short and very short description about the modules. We'll learn the details in the lecture series if you want to know about these objects. The course object means if university designed this object, then what is the objective behind it? First of all, to introduce process flow, you should have the knowledge about how the hierarchy done. Means what is the process flow of any design, VLSI design. Then you know the MOSFET operation in the subject EDC, but from VLSI design perspective, what should be the MOSFET operation? Okay. Then what is the design matrix? What is the different trade-offs, different performance parameters? Okay. Once everything is clear, then you should be able to design, implement, verify the combination as well as sequential logic circuit, but from the MOS design style. Okay. Then some short exposure to hardware design and programming. So there's an objective for the syllabus. And this outcome is once you will be familiar with the subject, once you will learn the subject, what is the outcome, what is the result? So if you will learn this subject, then you should have the knowledge what is the processes used in VLSI design and different types of tools. Okay. Then once you will learn the CMOS combination sequential circuit, then you will have the detailed knowledge of working of various circuits. And you can design any circuit from any style. Okay. And you can do analysis means performance parameters means like what is the delay, what is the power dissipation, what is the noise margin. So you can relate everything. Okay. And you can design and realize any circuit for any given specification. These are the outcome that is desired after learning this subject. These are reference books. I have already mentioned Sangmo, Kang, and Yusuf Labilisi, P. Umaira. Frank White is basically for BSD and Verilog design and for RTL design also. That is for the last module. Otherwise, the whole module 1 and 2 books are enough. Basically, one book is enough for the 1 to 5 modules. These are the list of software for layout experiments, electric VLSI. These all are open source software, Magic, Micro, NANOHUB, LASI. Micro is not an open source, but you can find the cracked version of it. Okay. These are the links. I'll copy these links in the below. You can copy this link from this description. Then these are software for circuit simulation. These are software for the layout experiments because you are learning the layouts of all the circuits. So this is for layouts. I always prefer the micro software for the layout. And this is for circuit simulation experiment. Circuit simulation RTSPICE, SPICE, PSPICE, Multisim, AngSPICE. But I have used RTSPICE, PSPICE, and Multisim. These three I have used. Thank you very much. If you like the subject, you want to learn the subject, please follow my lecture series. Please like and subscribe if you want. God bless you. Take care. Bye.